Can somebody do me a solid and if you have a computer already, maybe just double check the live stream that you can hear audio? If you go to the meetup page, there's a link to the live stream and you can go check and see. Okay. I do play your laptop screen. There we go. No, let's get cut off a little bit. But okay, so I'm Eric. You guys are here at YYC and down here at Last Best. And so today we're going to be talking about Elm. And this one's in a collaboration with the Functional Programmers YYC group here in Calgary. So I don't know, maybe I'll run through this and then maybe you can do a quick intro of your group and what you guys are doing. Alright, so we're trying to do a little bit more cross-functional stuff with a bunch of other dev groups here in Calgary because there's lots of good stuff happening. So two of our presenters, we got Matt, is going to be coming up, you're going up first on the mic, right? Yep. And then Paul, going to be giving us kind of the intro to Elm. And so some of our community partners here, so we got Clio, so Tyce's here from Clio, they're always hiring people, still hiring people, so if you're looking for work, go talk to them, and they do support remote as well. So Pixis Innovation, I believe they're actually hiring too, and I think they are looking, from what I remember, they're looking for PhD people doing stuff in Infobase and/or mapping, GIS stuff. So Last Best is here. You guys, 3 SIs changed now.
Yeah, 3 SI.
So yeah, so 3 SIs. You guys are hiring 2 right now, too. So we've got a couple spots. So App Carousel, I think, is looking for mobile devs. If you're doing any mobile stuff. We've also got Goodbits, which runs the newsletter. I sent that out today. If you happen to see it, Lighthouse Labs, they just finished up one of their cohorts, and they've got a few people that are looking for work too, I think. So we got 1, 2, nice, 3, sweet. And I wasn't able to make it to the demo yet, but I actually heard that it was pretty impressive. One of the best ones that I've had across Canada, actually. And I've been out to one in Vancouver and one in Toronto. Not to necessarily knock some of the formal education, but I was pretty impressed with what people were getting accomplished in the it's 8 weeks, right? 8-week program. Yeah. Some of the community partners, we've got stuff going on with Shiki, Places and Lights, YYC Ruby, they all have stuff coming out. We'll send out some of the stuff that's coming up pretty close or in the next couple weeks in the newsletter. Startup Calgary, .NET user group, now stuff with functional programmers. Everybody's kind of come together, which is sweet. And then next month we're going to be doing another collab with Pi YYC. So we're going to be talking about real-time microservice architecture with open source tools. So yeah, you can check out Meetup. It's up on there and has the full description. And if that's your jam, we'll see you next month too. So without further ado, why don't I get Andy up here, and he can talk about the functional programming group, and maybe if he feels like doing an intro or whatever, and we'll get going.
Yeah, that'll be real quick. So we reached out to Eric to do a collaborative thing just recently.
It just sometimes kicks if you talk too loud, I think.
All right. Matt was thinking of doing an Elm thing with our functional group, and I thought, hey, let's reach out to the JavaScript community because obviously there's a relationship with Elm and the browser and stuff. So we decided to do a joint thing. The functional programming group, you'll find us on Meetup. We're about 150, I think. Adam, I know Adam is one of the guys that helps organize it. But I think we're about 150, which is a lot smaller than the JavaScript community, but it's still significant. We try to do something once a quarter, a little bit more often than that. That's it. Thanks.
Thank you. All right, so was anybody able to kind of double check that we got the live stream and audio working? Yeah. It's good? Okay. Because I'm kind of, Hangouts sometimes is a little flaky for us.
Sorry.
All right. So I'm going to make sure that everybody can see what's going on online. Other stuff. And it's always a little bit of an art to get this playing nicely. Okay. We're going to go. No. There we go. All right, Matt, give her.
Okay. Hello, everybody. Thanks for coming. Thanks for the introduction, guys. So I'm Matt Hughes.
I want to make sure you're sharing the right screen.
Maybe I'll just see your.
Sure. Do you have the Hangout window? Yes.
Now, working. Oh. Okay.
Yeah, you're good. Okay. You're good.
Okay. Okay. I'm Matt Hughes Paul Coyle. we're here to talk to you about Elm. So what we're going to do today is just kind of walk through a quick tour of writing something really simple in Elm, just a really basic game, and introduce some functional programming concepts. We're going to go really quick and gloss over lots of stuff, but I hope to give you just enough of a feel for Elm and its syntax and what you can do with it, that you'll come away wanting to learn more about Elm, how you might use it, and more about functional programming. So I'm going to actually present. There we go. Okay, so I recognize some of the functional programming meetup group guys are here, so they know functional programming. Who else is here familiar with functional programming? Heard about it before, you're here. Who would call themselves a functional programmer? Yeah, yes, maybe. Okay. So I'm just going to start off by talking really at a high level about kind of my definition of functional programming, and it's going to leave lots of stuff out, but it's kind of the basic thing. So at the very basic level, functional programming is all about just working with stateless functions. And what I mean by stateless functions is just that they're functions that only operate on exactly what you give them. So you give them some inputs, they do some computation or some data transformation, and they give you an output, and that's it. They don't have access to global variables, they don't have access to like member data like you might have in an object-oriented language. It's just explicit inputs, explicit outputs. So you can't do I/O, you can't go out and get a random number from a random number generator. It's immutable, so you can't, there's something called variables, but they're really just, variables are just names for data. You can't ever change a variable once you've assigned it. With side effects, obviously you need to be able to handle input, you need to be able to draw stuff on the screen, but that's very tightly controlled. And functional programming languages give you a way to manage those things and reason about them very carefully. So you can't just do I/O whenever you want. All of that stuff gets pushed to the edges of the program, and in Elm, it's handled by the Elm runtime and handed off to JavaScript. So from a programmer's point of view, working in Elm code, you just focus on your own code, on what it's doing. The nice thing about that is if it works in a test, you can get some test cases and get some good test coverage on your functions, you know it's going to work. You know every time you call that function, you're going to get the same result if you're doing the same inputs. So if functional programming is all about working with stateless functions, then what makes a functional programming language special? And I mean, because you can write a stateless function in any language. You can take a JavaScript, you can write a function that just takes a couple of integers, adds them together, gives you the result, something like that. But what makes a functional programming language is that it's really actively hostile to side effects. It makes it really hard or impossible to write side effects. So for Elm, for example, you can't access global memory. There's no global state. You can't access it. It just makes it really hard to write that kind of thing. But at the same time, it gives you additional tools to be able to do useful things. So we're going to show you some of those tools that Elm provides as well. So I think functional programming is pretty awesome, and I hope some of you do too. And part of the reason for that, and what really brought me to functional programming originally was when I heard about Clojure's concurrency story. So Clojure is another functional programming language. It runs on the Java virtual machine. And the big selling point of Clojure at the time it originally came out was all about how it handled multi-threading things. So if you're working with stateless functions and you're giving them explicit inputs, you don't have to worry about multiple threads changing the same data at the same time. And Clojure gives you some interesting tools to handle sharing data between threads. But for the most part, you don't worry about it. You just don't have a whole class of problems that you might have with multi-threaded programs in Java. In JavaScript and in Elm, we have different kinds of problems. Instead of multi-threaded stuff causing deadlocks or creating bugs, we've got all kinds of asynchronous operations going on. input coming in, but we're trying to do HTTP operations, get some JSON from the server. And so probably everybody's dealt with these big call chains of callback functions in Node.js or something like that as well. And Elm gives you some new tools to reason about that. So why Elm? Or what is Elm? So Elm is a completely separate language. It's completely separate from JavaScript. It compiles down to JavaScript. And the reason, the reason I point out that Elm is completely separate from JavaScript is, unlike other languages like Clojure or CoffeeScript, which kind of try to improve on the JavaScript syntax a little bit, Elm's completely separate. It's a completely different way of writing JavaScript programs. And because it's compiled, the compiler can do a whole bunch of neat stuff for you. So it has a type checker in it, which can eliminate a whole class of bugs. It has an interface to JavaScript, so if you wanted to start integrating Elm into your large AngularJS code base or something like that, then you can just start doing that. And it has a very specific way you get values and data from JavaScript into Elm and values out of Elm into JavaScript. So you can use that to start putting Elm into your project, or you can use it to integrate other kinds of web APIs. So like we have audio, WebSockets, Canvas, there's all kinds of things people have written Elm libraries for. So it lets you do quite a bit of really cool things.
Good question.
Yep.
So does it, oh, you answered it there. It might compiles to JavaScript.
It compiles to JavaScript.
Ask a question.
Yep.
Is there a functional language that it compares to this?
I would say it's probably pretty similar in some ways to Haskell. The way the functions are defined and some of the other stuff is very similar to Haskell. It doesn't have do notation.
Does it have a runtime?
It has, in the sense that there's quite a bit of support code for it.
Like libraries and stuff?
So if you were to go to elmlang.org, elm-lang.org, and download the installer for Elm, you get a whole bunch of interesting tools. So one is Elm Reactor. And Elm Reactor basically is a little program. It starts like a web service that you connect to your browser, and that will take an Elm file off your disk, compile it for you. If you've made any mistakes, it shows you the world's friendliest error messages, which is pretty cool. And if you haven't made any mistakes, it will run the program. So that's a nice way to quickly, iteratively write your program and test it out. Elm make compiles the Elm to Elm.js and index HTML that you can kind of build into other things. It gives you a little REPL, a redeveloped print loop, so you can just run it on the terminal, try some stuff out if you want to get a feel for the syntax or whatever's going on. That comes in handy. And then finally, Elm package, which allows you to search, install, and publish Elm packages. And one cool thing about Elm packages is that they're semantically versioned, and that's enforced by the compiler. So if you make a breaking API change in your package, it forces you to bump your version number. There's kind of two others that have come up through the Elm community. One is Elm format, which will take your Elm source code and reformat it so that it's pretty and conforms to community standards around that have kind of come up in the community. And then another is Elm test, which is an NPM module that helps you write your unit tests and run them. So why might you want to use Elm? For me, getting started with Elm, I found it to be the most accessible functional programming language, or really accessible language of any kind that I've used in a long time. It was just super easy to get started. You can go and use elmlang.org/try and start typing stuff in and playing with it and doing experiments. Once you learn a little bit of the APIs that you have available to you, it goes right away. And the nice thing about Elm and its try thing is because Elm is designed to build web pages, it's designed to do interactive stuff. What you can do with try on the web page is so much more kind of fulfilling or interesting than what you might try. You can go to Hotstepper and try it out, try that out as well. But it's kind of you might write a quick store
Fibonacci sequence or something like that. This you can actually, try stuff out and make little games where you try them. Yeah, the examples are also really good to kind of walk you through, drawing pictures, validating forms, and it's an easy way to get started, and really short pieces of code that give you a really good idea of what the Elm API looks like. Elm is so easy to get started with that the McMaster University Computer and Software Outreach Program actually uses Elm to teach grade school kids programming. So I'm hoping, these are some, I think, grade 8 kids, and they're drawing stuff and animating it in Elm. So I hope if some grade 8 kids can enjoy Elm, I hope everybody else can as well. Finally, going back to that accessibility thing, if you're trying to learn a functional programming language, sometimes it's easy to get kind of bogged down in a whole bunch of abstract math vocabulary. And Elm is the creator of Elm has gone out of his way to say, don't talk about things in general terms, okay? If you want to talk about an HTTP library, talk about an HTTP library. If you want to talk about WebSockets, talk about WebSockets. Don't worry about the general stuff. That'll come later. So that, because of that focus, you can, if you already know, I want to do some forms, I want to do some HTML, I want to do some Canvas work, you just go and you find the package you want to use, you read the API, and it's all kind of very clear. If you know the right technologies and you know some basic functional programming stuff, you'll be good to go. You don't have to learn it. But it's all there. If the concepts still apply, if you want to learn it later, then you can. Okay. There's a whole bunch of reasons to try Elm. Probably one of the things is the world's friendliest server messages. I'm not sure if you try to live codes and stuff a little later, you'll probably see some of those. All right, so let's build something. Nothing to talking. Has anybody here played agar.io or Agario? Yeah, a little bit. One guy. So the base. Hey?
It was on House of Cards.
It's on House of Cards. There you go. If anybody hasn't played it, the basic idea is you kind of float around in a 2D thing and you try and eat food or eat other players. So I'll just show you where I'm kind of going. You won't get this far, but this is the basic idea. You're kind of floating around, you go for the food, you get some points, you get a little bigger, you get a little slower, and then this one needs some multiplayer so that other people can come in here and try to eat me. But that's the basic idea. So we're going to take 1 or 2 little steps towards this prototype tonight. Okay. You see that okay? Okay, so this is try Elm.
So if you want me, I can hold the mic for you, or if Paul wants to narrate, depends on.
Well, hopefully I don't have to type too much. So
Okay, cool.
I'll hand off the mic if I need to.
Okay.
Okay, so this is pretty much the world's simplest Elm program. And all we're doing here is printing out hello world. So this is try Elm. You can go and click compile and it'll do this. This is actually from the example page. So we'll just kind of run through the syntax a little bit here. So basically we're just importing HTML. We're only pulling in the text function from the HTML package, and then we're just going to call that text function. All that text function does is it takes a string and closes double quotes, and it converts it. It converts it into an HTML object, or value really, that Elm knows how to render onto the screen. And then we're just feeding that into our main function. Okay, so all we're doing to call the function is just listing its name and then the arguments to the function, and that's it. There's no parentheses, there's no semicolons. Pretty straightforward and easy. Okay. So the next step is, I showed where I want to go, which was this thing, and not, other than the text down here for the store, we're not drawing text. So let's try drawing something a little more interesting. So the next thing I'm going to do is
pull in a few more packages. So graphics.collage is an Elm package that basically wraps the canvas from HTML. So I'm pulling in the Elm or the collage package, and I'm exposing everything because I'll probably use everything as we go eventually. And I'm also pulling in all the colors. I really only need red for this particular example, but here we go. And then I'm building up. I'm calling a series of functions to draw this circle here. So I'm just going to start in the innermost one, which is with the circle function. So circle 50 basically says, give me a shape that's 50 pixels in diameter. That circle is taking an integer and it's returning a shape. So at that point, the shape hasn't got any text or texture or color on it. All it is just a value that describes the circle. The next thing I'm going to do is I'm going to fill it with a color. So now I'm going to take that shape and I'm going to convert it to a form. And what fill does, I'm just calling the fill function. I'm giving it a color, red, and I'm giving it a shape. And that returns a form, or what this package calls a form. Again, just a piece of data that describes a red circle. And then finally, I'm going to put that in a list. So the square brackets in Elm are a list. And
Just wondering why main doesn't have a type signature.
In Elm, type signatures are optional.
Okay.
So you, sorry?
If it can be inferred, you don't need to declare.
Exactly. So the question was, why does main not have a type signature? The answer is Elm doesn't make you do type signatures. If you turn on the warnings in the compiler, it will complain about lack of type signatures. But you don't need them to get started. Lists in Elm are denoted by square brackets with commas between the elements. So I'm just giving this a list of a single item in it, and I'm calling the collage function. So collage just gives me basically a canvas that is 320 pixels wide by 240 pixels tall, and it's going to render this list of forms on that collage. The last thing I'm doing is calling from an element. So that's taking my collage element and converting it into an HTML thing, so I can feed it off to main, and so that Elm can render it. All right, any questions about that?
So, since this compiles to JavaScript, is that the rationale for not just always importing all the functions from HTML, for example? You're just limiting it to those two functions. Does that reduce the size of your JavaScript?
It's more about, it may. I honestly actually don't know the answer. The reason that I would tend to use just things like that I was going to use in a module was just so I didn't have a whole bunch of functions from different packages colliding.
I can actually I'll just add a little bit more to that. So what's happening here is this is for readability in terms of succinctness, I think is what Matt's going for, but what you're asking about is whether or not it includes less code in JavaScript at the end. And the answer is yes, but it doesn't do a very good job yet of bringing down the amount of code that's supported. So if you bring in graphics.collage, you're getting the whole thing irrespective of what you expose. So it's bringing the whole thing in, and effectively for your base level Elm project, you're looking at about an uncompressed amount of about 350K JavaScript. That includes the runtime, that includes most of the often used stuff. So that's what to tell you.
Okay, I'm just going to jump back to the slides here. We're building stuff. Okay, so Elm's been around for about 4 or 5 years, I think. And over that time, so the community that works on Elm has arrived at a certain architecture that is used to structure Elm applications. And it's called the Elm Architecture. So what we're going to show here is a simplified version of that. We're not going to use the more complex version. But this is a pattern that is widely used to structure your Elm applications. And so on the right-hand side there, we've kind of got the orange blocks,
which are effectively the outside world. So, and by outside world, I mean stuff outside of your Elm code. So you've got your inputs, keyboard, your keyboard inputs, mouse movements, window resizes, HTTP responses coming in, and then on the bottom, the HTML that you're rendering that's being displayed to the user on the screen. The stuff to the right of that, the blue and green stuff, is everything that's written in Elm code. So you've got the blue boxes with the actions in the model, and those are just data. So those are Elm data structures that represent the actions represent inputs that are coming into your program, and then the model is basically a tree-like structure of all of the state in your application. So probably then you've got two functions, basically the update function, which knows how to take an action, the previous state, and compute a new state, and the view function, which knows how to take your state and convert it into an HTML object that Elm can draw on the screen for you. Okay, so I'm just going to go back to the code here. So Elm has this package called startup. And what I'm doing here is importing the startup here. So I'm just going to take the simple version and call it startup. So the simple version has a single function in it called start. And what that takes is a record that describes your application. So in Elm, a record is denoted by these curly braces, and they're kind of analogous to JavaScript objects or objects in other languages. The difference is that in Elm, you can't iterate over these things. You have to explicitly name them because they're part of what's type checked. So you can't like add a new field to a record at one time. It's compile time. It has to be there. Can never be nil. Can never be null. Elm actually doesn't have nil at all, which is nice because it helps avoid runtime exceptions. So what we're doing here is calling the start function with one argument, which is this whole record. We're giving it a model, which is right now we're just going to have an empty record. So there's no data in our state. It's just an empty thing. And then we're passing our view and update functions. So this is kind of once you get beyond stateless functions, the next step you need is first class functions. So functions that are things that you can pass around and pass to other functions and things like that, or put in records is basically. So we've got two functions defined here. One is our update, which takes two parameters, and the signature of this update function is driven by startup. Startup requires us to provide an update function with two parameters, and likewise it requires a view function with two parameters. So far nothing's really changed. We have our update function is doing nothing. It's ignoring the action parameter, and it's just returning the model. Our view function is exactly the same as it was before, except for now it happens to take an address in model, and it does exactly what it did before. So I can define that, and we just look at what's on the screen. Okay. So the next step that we can do is to kind of build out our model a little bit. So what I'm going to do is just take all of these hard-coded values that I had in the view function and pull them into our model. So now we can imagine resizing a window if we want to do that and having width and height change. Or as Paul will show later, we'll be able to change the radius and the color of this thing that we're drawing. Okay. So here's another try Elm with that model extracted. And now the next step is that we're going to change our view function to use that model to change the collage so that we're actually pulling the model or pulling the data out of the model and actually using it. So we can run that thing. There we go. Okay. Any questions about that step of that? It's pretty straightforward. It's still kind of boring. We're really not doing anything. So we want to I want to keep going here. Okay. So step 5, we need to be able to model inputs coming into our program. So what I want to be able to do is move my mouse around on here, and I want that red dot to follow it. So that wherever I have my mouse, I want that red dot to draw itself. And what we're going to do is we're going to make use of this address parameter that startup gives us. And what we want to do, what that address does for us is it's kind of our way to get input into our program. So remember, the view function is just returning a data structure, a value that describes how to render the HTML. It's not actually rendering it right away. Elm takes care of that later. We don't need to worry about it. But what we can do is we're going to add a div around our collage element, and we're going to add an attribute on that div. So almost all the functions in the HTML package take 2 arguments. One is a list of attributes, so just be like an attribute in an HTML tag, and then another is a list of child elements. So what we're going to do is add an attribute so that when we move our mouse, what we're saying here is we're going to call this function which returns an attribute, and that attribute says whenever we move the mouse, send an event to this address. Send an event to this address. And what Elm will do for us is take anything that's sent to that address and turn it around and call our update function with it. So I'm going to kind of skip over the next part because I don't want to explain all the syntax and stuff that's going on in here. But basically we can bind to any HTML event. So in this case we're going to bind to onMouseMove, and we're going to send a message to this address. And what we're going to send is a message that says it's going to give us the X and Y coordinates of the mouse. So the way we're going to represent that is by using a union type. So we've got an action type, and that can be, right now I've only defined one type of event that can happen, but we could add more. So if we wanted to say we wanted to keep track of keyboard presses, maybe we want to know whenever the mouse, the space bar is pressed or something, we could add another union type to that. Do you have a question?
Yeah. So on line 29, where you have onMouseMove there, that's your own function you define?
So this is a union type.
No, sorry, not there. I guess it's 39. Inside the div there in the attributes, you have the onMouseMove function there, and it looks like you defined it.
So yes, this onMouseMove function I defined down. Yeah.
Okay. So you can define functions like later in the file instead of before you use it.
Yeah, you can define functions in any order, which is pretty.
This is different than what I'm used to.
Yeah, so I basically defined this onMouseMove takes 2 parameters, the address, and some function to call. And what I'm passing it for that function to call is this mouse move, which is just a constructor. It's basically a constructor. So whenever you do a union type, this union type needs 2 parameters to it, the 2 ints. So my onMouseMove function will call the mouse move and give it the X and Y coordinates of the mouse. So I'm gonna hand wave this onMouseMove function a little bit, just make it works, and here you can see that it does. So the only difference now that I've done is I had to add something to my model so that when I receive that mouse move event in my update function, that I was able to store it somewhere. So I had to add this position X and position Y of my mouse to my model. So that's kind of the first step. And then the next step is I need to actually change my update function to actually store that in. So now where our previous update function did nothing, it just returned the model directly. Now we've got something much more interesting going on. So Elm has come along with these union types it has pattern matching. So, and the nice thing about pattern matching is that if I did have a whole bunch of different parts to my union, Elm would require that I case match every single one of those. So there's no way for me to miss a case that I might need to consider. The compiler will tell me, you know, you're missing something. So we can actually do that. And so it's going to complain that I have a missing pattern match.
What's the double slash operator?
So Elm doesn't implicitly do any conversions. So what happens here is that this x and y are ints, and double slash is integer division. Is what's happening there. And then I'm doing this computation, which is a coordinate-based conversion, because the mouse coordinates are 0, 0 in the upper left-hand corner. And the way the canvas works, or the collage, is that it centers 0, 0 at the middle. So I need to do that coordinate system conversion. And I also happen to know that the collage API uses floats for everything. So I convert those ints from the mouse input into floats. So there's a couple of, I mentioned the pattern matching here with the case statement. So in pattern matching, I'm matching up my, actually the mouse move type, extracting out the x and y, and then the arrow says, whenever we see that match, do this stuff here. So I could call a function, or do whatever I need to do, but I'm just going to do a record update. So records in Elm, the record update is very similar to defining a record in the first place. The only difference is that you've got this vertical bar. So this record update syntax is saying, take this record from the model variable, pipe, and then change these two fields to update them to these values, basically. And that's all that is.
But it's immutable, right? So it's not changing, it's creating a new.
That's right. So the question was, it's immutable. Yes, everything in Elm is immutable. It's based on efficient data structures for immutability. So if I were to pass this model to some other function, it would like this would return a new value, a new record basically, and I could use the original model and with the original values.
Does it do structural sharing like Clojure?
Yeah, it's based on a similar set of data structures to Clojure that share all of the data, so that you don't have to. This copy isn't actually that expensive. It's quite efficient both for access, update, and sharing. Okay, so we've got the position of our mouse into our model, and then the next step is to actually change our view functions so that we actually move the model around. So that's the addition of one function call here. So this is the move function from the graphics.collage package. It takes a tuple. So in Elm, a tuple is just a closed in parentheses and has a comment. So it has different from a list, it has a fixed number of elements that always have to be there. And so the move function just takes that and I'll just get that up. Okay. I think we're down to the last part for me, which is, everybody likes, if we're going to play a game, you want to have a score. So we're going to add a little bit more to our model so that when we move around and we eat some food, our score goes up. Yep. So can I describe how, when I move the mouse, the functions are chained together? I can handle it a little bit. I think Paul will cover it a little bit more as well.
I'll come over some things that are applicable.
But the basic idea is that this attribute here tells the Elm runtime I am interested in listening to mouse move events. When a mouse move event occurs in this div, it's kind of hard to see, but it basically says create this action. So if we go back to this diagram here, our input is the mouse moving, the raw JavaScript mouse move event. We're giving Elm the tools to say create an action out of that event. And that's this code here is create that action and send it to an address. And then we're kind of going to hand wave around that a little bit, but basically sending it to an address results in that update function getting called a little later on.
So on is a built-in function from one of the imports, and it returns the action.
It actually returns an attribute. So this is a list of attributes. When Elm takes this description of the HTML and converts it, in the Elm runtime, converts it and actually displays it on the screen, it knows how to look at that attribute and convert it into something that actually starts to handle the events. Yeah. So I'm just gonna build this a little bit more. I'm gonna add a score to my data model. I'm gonna add some food at fixed locations. You can see in this one I was adding random numbers at different places, but this is just good enough to get started. So the first thing is we want to update our view to show that those little food bits. And the way I've done that is I actually went and I complicated this example a little bit. So I introduced the let syntax here. So what let does is it gives you a way of binding names to data. So in this case, I'm binding my blob object, which we've seen before, where I've got my circle of a certain size and of a certain color and moved to a certain place on the screen. So I'm defining a name for that piece of data. I'm partially evaluating the collage function. So I'm giving it the width and the height. And that was just to make this function mostly to make it a little bit shorter so it's easier to fit on the screen. So now my collage function, where it used to take two ints in a list, my collage prime function has been already evaluated these 2 ints, and all I need to give it now is a list. Yeah.
Are all the functions curried automatically?
Yeah.
So it's not like the prime you're using is like a special syntax for partial application. They're just curried. You call them less than the number of arguments they need.
Yeah.
They store those, and then they get all the arguments they need. And they execute.
Exactly. So the question was, are all functions curried in Elm? And the answer is yes, they are. So if you have a function of multiple arguments, you can call it with some of those arguments, and it returns a function that takes the rest of the arguments. Yep.
So the collage prime, why didn't you have to use let?
Why didn't I have to use less?
Let. Like why didn't you have to say let collage prime equals? It's in a block.
It's it's in a block. So there's only 2 places in Elm where indentation matters, and this is one of those places. So everything under the let block defines a new name basically for data.
It's like defining multiple variables with a comma.
Yep. So I'm basically defining these 2 values or variables, and in this chunk of code, which I just messed up, I can then call those functions. So I'm just taking that collage prime, and I'm giving it a concatenated list of data. So double colon is list concatenation, so it takes an element that's not in a list, and it takes a list and it squishes it together. And then if you're kind of only heard about functional programming a little bit, you might be familiar, you might know about mapping over a list. So this is kind of one place where we can just do that. We're using a list.map function. We're giving it a function which takes a particular data type and converting it to another data type, and then we're giving it a list to map over. So viewFood just takes, this is a little bit different syntax. So up here I've got a whole bunch of parentheses so that my evaluation order happens in the right way. And down here I'm using a slightly different syntax, which once you get used to it is more readable. But this is basically saying take a circle, call this circle function with whatever radius is in that radius, and then thread it into the next function call. So where up here I had to call fill, color, shape. Down here I can call fill, color, and this this operator, this kind of arrow operator thing, automatically takes the expression above it and feeds it into the fill function. Yeah, it pipes it into the other things. Yep. Pipes. That's right.
Is Elm lazy? Is that why you have to do the explicit control of your operations?
I don't think it's lazy.
Not lazy.
It's more just that the function evaluation just you start with function name and then it just evaluates arguments in order. So if I didn't have the brackets around this one, for instance, if I didn't have these brackets, these parentheses, it would say fill, color, function. And I would try and use that function and it wouldn't type check and at the end. So any questions about that? All right, that's pretty much all I had. So I'm going to pass it over to Mo.
Okay. Thank you, Matt. That was a really good introduction. So Matt's all fun and games. Let's do some enterprise now. I know that's what everyone wants to do, right? Okay, I don't know if I'm set up here, so bear with me for the first bit, and then, oh, we have a question already. You love enterprise? Tell me about it. Of course. There's like 8 SOAP libraries for it. It's awesome. Yeah, everyone walks out. Okay. So bear with me because I don't know if the Elm reactor is set up.
It's running it.
Okay, so hopefully that'll work. So anyways, what I want to do is extend from the awesome intro that Matt gave. It gives you a flavor for Elm. And I want to expand upon the Elm architecture. Because if you end up coming into Elm and wanting to do something semi-productive rather than just, no offense, but just drawing some shapes, you want to make some reusable code. You want to start using that in multiple places, and you want to see how you can structure a larger application. I think that's pretty important, so let's look at it. I will gloss over a few things, so ask questions. It's okay, but I'm sort of assuming that you picked up on it, and it seems like a few people did actually. I'm surprised. Picked up on what Matt was talking about. So again, just stop me if you need to, and I'll try and make it succinct. So I'm going to review the Elm architecture from what Matt was telling us about. So this is the simplified architecture, but it's still very useful. So it starts off all with actions. Actions are what cause things to happen, causes state to change in our application. This is the one true way of knowing that state's about to change. Actions get propagated down and they get folded into a state object. So we have our, for instance, our application, it gets an action, and we say, given the current state of our application and this action, let's produce a new state. So that's where you get that sort of line that comes up. It's replacing the state after you fold these things together. And that's just a functional term for taking two pieces, one is a list, and pushing them together and creating something new each time. Stop me if I'm wrong, by the way. So from that new state in the Elm architecture, once we get an action, we create a new state, it's our new data model, we generate a view. That's the HTML, that's what people see, that's the important stuff. Some might argue that, but that's the important stuff, that's what we see. So every time an action comes in, we generate a new state, we get a view. Views are where actions also get generated. So on a mouse click, on a key press, on anything that we've defined in our views that have DOM events, we're going to map those to actions if we need them. And you saw that in Matt's example where he had mouse move. So we mapped mouse move to an action that takes two integers that just so happen to be great. That's exactly what we get, really, in the event of a mouse move. And we map it to an action, and then it gets propagated back up into the application, and we modify our state accordingly. Right? So we all just saw that. And then, of course, there's the outside world that Matt talks about, and this is, this is things that are maybe controlled by the user, but aren't actually explicitly actions that are generated from within the Elm project. So you resize the browser, you get it, you get an input, we map those also to actions. So we're trying to take all of these time variant user input or just things outside of our control, and we're going to map them to actions so that every time an action comes in, it's a controlled state change, right? So that's what's happening here. So if I'm going quick, I'm trying not to waste any time. But really, the crux of it is that this is the update portion. This is the portion that really changes everything every time. We get an action, we change the state. I want to sort of enforce this before we keep going because it'll make a lot more sense as we go along. Yes?
Are there persistent data structures in the structure?
You have to build them yourself. Okay, so from the outset, sorry?
Do you mean persistent data structures like closure style persistent data structures?
Oh.
Can you repeat that question?
Yeah, okay, so sorry, I'm sorry. The question was, are there persistent data structures in Elm? And I said, I don't know. And then he said,
yes. Like is
it like a closure?
Anytime you're doing
Talking
structure.
about the discussion was sharing the closure JUR.
You were gone earlier when I asked the same question.
Okay, there's discussion going on for those at home. Yeah, maybe. I'm not familiar enough.
There is.
I'm going to get to the state. I actually have a whole section on the state. So I'll get to that. Whether or not it maps to closure, I cannot answer your question. Perhaps it's general.
It's similar.
It's similar. Okay, Matt says it's similar, so I believe him. Okay, so this is the key portion here is the update. So the way I like to think about components in Elm is that they're helicopter parents. Now this is true. So when you have a parent, so the main application that Matt made is the top level parent component. We'll call it that for lack of a better word. Any child components that it creates, it holds on to the state. It actually owns the data that defines the state of those children. And this is different from object-oriented and even JavaScript, where oftentimes it's the instance of an object, or in JavaScript I'll call it a closure, different from maybe perhaps what you're talking about, but like a closure wherein you define variables that you cannot access from the outside. They are private for all intents and purposes. That doesn't exist here. I'm the parent, I own everything that describes my child. Not only that, I also decide when they update, and I also decide when to render them to the screen. So really, I'm an all-controlling parent, right? And I think that I love this picture, personally. I don't know, I think it's good. It's terrifying, but I love it. So this comes down to nested state, and this is actually where this gentleman over here was talking about. How do we maybe, correct me if I'm wrong, but how do we sort of portion off parts of states so that we're not just holding onto this big blob? Okay, so you jumped ahead, but that's okay, I won't hold it against you. But let's just quickly talk about what this means in terms of data modeling. It actually kind of makes sense if you think about it. So a component can never be truly fully described unless you describe all the things that are inside of it, right? I mean, the absence of any one of those things technically changes its meaning. The obverse to that is that a child component, so something that's contained within something else, they only really make sense when they're in the context of a broader piece of data. How they're used, what the sibling data, for lack of a better word, is around them. And so, just as an example for this, there are, there's applications where you can take the state of something and reproduce it in the browser. And I'll talk about that later. You can reproduce it in the browser at a completely different time. Anyways, this nested state also just happy path maps well to the DOM. I mean, the DOM elements are nested. It's a nested data structure. And if we create components that nest, well, then they'll map to our state. So anyways, okay, this slide doesn't work great, but so the upshot is that the top level application holds everything. It's a huge blob of state the larger your application gets. The good part is that it's fully described. So like I mentioned before, it's not such a bad thing to have this huge blob of data that actually describes your application. Consider this. You have a production application and your clients are having problems with it. You could actually have something in there that produces a JSON representation of the entire state at that exact time for that exact client, push it to your server, reproduce it in QA, exactly. No steps to reproduce, none of that, right? You just basically unfreeze the data as where it is. It's kind of cool. So anyways, so you might,
in that way, it's kind of similar to Redux.
it is similar to Redux, but actually the Elm architecture is simpler, you'll find.
Seems like it already.
Yeah, you'll find that it is, but Redux actually encompasses a lot of these same fully contained state ideas, and then transportable state, I guess, is what they call it. I can't remember. So yeah.
I'm probably totally jumping ahead here, but is that how the time travel debugger works?
Yes. Okay. And I will say no more. But yeah, time travel debugger, if you look it up, because we don't have the time to get into it. But effectively, what it does is as you make changes, remember I was saying those actions come in, it modifies the state. Every time one of those actions comes in, modifies the state, it stores that. And then you can replay the state back and forth and walk your time. Sorry, sir?
Oh, anybody who's uncomfortable with the idea of a giant, single, well-controlled piece of global state should be uncomfortable with the notion of a database.
Yeah.
Because they're the same thing.
Very, very good point. But not everyone sees that. A lot of people go, oh, I heard the global state is terrible. So this gentleman, just for the people at home, he said, you know, they should be uncomfortable with this, the idea of a database. And that's actually very true, because that is effectively done correctly. You're still controlling your data in a controlled way in one large state. So let me push forward. Mike? Okay, sorry. So what does the Elm architecture do? It's shards. I call it that. This is not a term that anyone else uses. I just call it that. So we have to not think about it as a global state. We have to think about it as a composite hierarchy of state. I know maybe that sounds enterprise too, but it really is. It's a bunch of smaller pieces of state that we glued together to form something more cohesive that really describes what it is we're working on. So there's no real explicit ownership of data. It's not like you don't have an object which owns its private data and only it controls access to it. There's no encapsulation here as you would see in the normal object-oriented world. But instead of having that sort of ownership of data explicit, it's implied through how we use it. It's implied through how we modify the data. And so in that way, the Elm architecture basically shards the data in a progressive way down this hierarchy to make updates and to sort of give a sense of ownership without really having ownership. So let's just give a quick example. If I'm beating a dead horse, I will jump ahead. So just tell me. So we have our top level state. This is Matt's application. Matt had a bunch of properties, but we're going to introduce a few components to it. We're going to focus on component A. Component A just so happens to have a nested component B within it. Excuse me, too many beers. Oh, right, okay, so each of these components has its own update function. It receives, it's the exact same thing that Matt showed. An update function receives an action, plus the current model, the current state, does some modification to it, and it produces a new state, a new model. So each one of these layers has it, and don't think of them as layers, but each one of these components, the top level included, does this. So the first thing that happens in the Elm architecture, based on that diagram I showed you, we have an action that comes into the top level, and it says, you know, oh, sorry, let me back up. Let's assume that we're updating component B. Okay? We have something that says, oh, component B needs to change. We have an action that comes in that represents that to the top level. The top level looks at it and goes, well, okay, this is all fine and dandy, but ultimately, I need to update component A. That's truly what this action is telling me. That's what the top level will see. Now, bear with me because it'll make maybe more sense later. So what does the top level component do? It shards off component A, which happens to contain component B, the state data, and it passes it to component A. It says, here's your action, here's what you need to update, have at it. Component A does the exact same thing, but it says, well, you know, to be precise, it's component B that needs to be updated. So component A shards off the state data for component B and adds it to, or sorry, sends it to its updated function. And then the result of that is just that the result of B's update gets stashed into component A's state. The result of component A's state gets stashed into the top level state, and we create a new state. That's that little loop that I was showing before. But what this is showing is basically that it just traverses down a hierarchy. Sir, is this close to what you were saying? No, it isn't. Okay.
So this is kind of similar, at least for me, it seems similar to passing like props in React, but it happens automatically. And like it's scoping the props to only what the component cares about.
Yes, okay, so the comment was that this is similar to React.js insofar as that you pass props down, and it is. It's actually more explicit, I would say, because, and you'll see this later, we have to do a fair bit of work to ensure that we know when certain, for this example, props get passed down, and which ones get passed down and what to do. Yeah. But it's very much the same. I mean, there are, you know, anyone here who's used React, there are a lot of analogies here. My personal feeling is that Redux is more complicated than the Elm architecture. Once you solidify the idea, this idea in your mind, I find it's a lot simpler. But yes, you're absolutely right. It's like passing props down. But this is to allay those fears for people here who have not worked with this kind of data and this kind of programming style, where they go, oh my god, there's a huge glob of data. What do I do with it? And I've heard that it's bad. I mean, you do hear this. So anyways, so that's what happens with the applications. Let's actually, oh, sorry, red shirt. That's a good question. That's a super good question. So the question is, when the update happens, does the state change at each stage of that propagation down the chain? So the answer is no. The answer is yes, but the actual answer is no, because it all happens as one chain of action. That you'll see later. We can form these composite actions, and Matt kind of alluded to it in the fact that these actions are composite, like they're union types. So it can be like a label plus other data entities, right? So what we do is we actually end up chaining these actions together so that we peel off portions as we work our way down the chain. Is that making sense? No? Maybe? Okay. But effectively what you're seeing there all happens in one shot. And because we're only dealing with a global state, that's the only one that really ever gets changed, so to speak. They change as you go down, but the true finality of it is that they all change and then it's a new state, global state.
So do they change when all of the cascading changes are finished?
That's right. We can think of it that way. Technically, I think the way it works is that as it goes down, it is changing each time that it happens, all as one sort of transactional unit, for better or for worse. Absolutely. Absolutely. This guy was a good student in school, I can tell. Oh, he's following along. Sorry, this is my presentational style. Anyways,
That's good.
We're making a menu. So why are we going to make a menu? Hold on, let me back up. We're going to make a menu because a menu is like super basic. And it's something that it can help us control attributes in our application. We can make changes with it. We can say, oh, this represents these selections. We're going to change one. And then it's also something that's reusable. And I want to sort of emphasize that portion because it's going to introduce you to a slight difference in the Elm syntax that you saw from Matt, but it extends it and it's not difficult to really grasp. So let's model a menu. Really all we have here, can you see the mouse? Okay. So we want a list of selectable items and we want to just give the menu a title. It's very simple. So we're going to define our model type. This is an alias, but don't worry about that. So a model of some type A consists of a title, that's a string, and a list of tuples that are some type A and some type string. So really think about A here as some type that just needs to be used consistently. If you want a model of type int, make sure you give it items that are a list of int and string. That's it. It's just enforcing consistency, but it's allowing us to circumvent the type check for an explicit type. It's basically, it's sort of along the lines of pattern matching, I think, is how it's working. So that's what our model is going to look like. And then to initialize it, really, we're just passing it a string, passing it a list, and it's going to give us A. So once again, you can see the consistency in type between A here and A here. So if I initialize this with some string and some list of floats and strings, I'm going to get a model typed with float. So hopefully that makes sense. I think for the functional programmers, this might make a lot more sense, but it really is effectively like a generic in some ways. So let's integrate it. We're already integrating this component. I'm not showing the methods that render the HTML because it's sort of not really as important here. So we're taking Matt's existing model, and we're adding a color menu. And color menu, so for this gentleman here who was asking about type definitions, I always put type definitions in because I'm an idiot. So a color menu, in this respect, we're going to make a menu that changes the color. So it's a type of menu.model. Menu is the package, but we're typing it with color. So that type variable, or that generic type A, is color in this respect. So now every time we use this, we have to ensure that that A variable is consistent every time, right? So we initialize it, block color, and a bunch of colors, and they're linked. No problem. And again, the parent holds the model. We have helicopter parents. So we render the view. So this does actually show it, but it's really showing what's changed. I'm just adding a function that calls the view function on the menu. This is you'll find the exact same methods. You'll have an initialize, an update, and a view, exactly the kind of ones that Matt specified when he wrote his. You'll find this down the chain, the whole way. You initialize something, you update that state, you get a new model, your helicopter parent, you retain it, and then you update given their actions. So we give it the current color to know what's selected. And I think I'm supposed to demo here, but escape. Escape.
It should be the second, third time.
Cool. 8. Can you see that? Okay, we can see it. So I've added this. Oh god, this is going to explode. I've added a new file. This is why this can't run on the Elm try, because it only takes one block of code. So this has got a second one. So if you go to GitHub and pull this down and check it out, you can see sort of how we set it up and then how you reference another module. So we'll run main. So now, here we go. Oh, can you see that? Okay, so sorry about this, it's a little small. Okay, so we have what Matt made. And now we have this simple little render menu where we have the colors listed, and you'll see that red is actually the selected one, which is the red blob we have here. But I can't do anything. I click on this, it doesn't do anything really, it's just a static menu right now. All it's doing is representing the fact that there are potentially 3 colors and one of them is selected. So it's pretty useless. So let's go back to this one. And then that. Okay, so that's where we are there. So, okay, how am I for time? Seriously, am I, okay, I just don't want to bore anybody. So we have,
so we want to get another like 15, 20, is that right?
Okay, I'm going to go fast.
Okay.
I'm going to go fast. So I'll try and be brief with this. The idea here is we want the menu to do something. We want to get the things that happen on the menu to somehow propagate through that Elm architecture that I was talking about. So we come down to the top level component, we can make some sort of changes. So what we can do is on Matt's code, we can change it so that not only does he have this mouse move, which moves the blob around, we have now an action that says, hey, change the color to this color. So in order to satisfy the compiler, we have to add that case to the update function. But really, we're just saying, take the color that we get from that action and change the color of the model. That's it. That's all that we have. But how does the menu know that we need to send that action? And how does it know where to send that action? And so I'm going to take a little sort of aside here. So in Elm, signals are used for routing events. For the most part, we're routing actions. And these actions can be composed of, like this guy was getting over here, is that actions can be these layered things that we iteratively strip off as we pass them down the update chain. But effectively, if anyone here has used any of the reactive libraries, it doesn't even have to be JavaScript, any of them, you're effectively dealing with time-varying signals. That's really all you're doing. And so this is just a very brief example of it. So signals can happen at any time, but we can merge them, we can bifurcate them, we can filter, we can do all sorts of things with them just based on functions. And so in this case, the example is that, you know, we have two signals, A and B, that both happening at different times, but the merger of them looks like this. I think it's pretty self-explanatory. Thanks. So anyways, that's really only applicable to people who maybe dealt with that, but they're basic, it's like a processing unit. You know, you're just, or sorry, a processing network. You're piecing together processing network units like this. Anyhow, the point is that this is how we pass actions around in Elm, and signals create something called addresses. You saw that in what Matt was talking about. So what we're going to do here is at the top level of code, this portion here, is we're going to say on the menu, we're going to define a context in which the menu operates. Right? So we're going to say, when you want to select something on the menu, please send it to this address called select in your context. That's what we're doing. Again, you can see the A type again. That is just making sure that we're consistent. So what we can infer from this is that the menu that's going to be getting this context, if it's the color changing one, we want to give it an address that accepts a color, right? So to keep type consistency. Hopefully that's not getting too weird. And so we pass it down. This down here is how a single item in the menu is rendered. This is just defining how it's styled for selection. But here we go. Remember Matt's on mouse move? This is exactly the same. So when we get a click event, we want to send it to the context select, this guy, for the first element of the tuple of the item, which is what? It's a color in this case, right? So we're consistent. Our types are consistent here. Is there any questions about that? Because I know I'm kind of gripping. Okay. So we're type consistent. Okay, everything's great. Next slide. Okay, so the last thing we have to do is now make that context for the child component. So the menu now knows, okay, well I have to say, when someone selects one of my items, I have to send a message to this address. But how do I know what the address is? So in comes the helicopter parent again. The helicopter parent says, hey, don't talk to anyone else. I'm going to give you the address to talk to. And we use that with this forward to syntax. And all signal.forward2 does is it says, okay, give me an existing address, and I will append, this is, we were kind of discussing how we make this composite actions. I'm going to append a portion of an action to that in order for you to complete that type. Remember, change color. Okay, note the action check is change color. And the context select is address color. So I'm basically giving it a partial function here. Does that make sense? The change color accepts color, but I'm not finishing that. So I'm giving it an address that once it receives a color, it completes and it does the action. It's finishing. This is the currying thing. This is the end of the curry chain. I didn't expect to get this advanced, so I'm kind of freestyling. So that's what's happening. Not for anyone else who's got it. We're basically, as the helicopter parent, we're telling the child, okay, just when you select something, just send it here. I know what to do with it. And then we just render out the view as normal, but we give it a context now. So now I don't. Next one. Okay, so, by the way, this is all in Elm Reactor. It's super nice to just like quickly build stuff with. But there are, for those JavaScript inclined people in the audience, there's Webpack plugins that do this kind of stuff. There's a number of things that are in the Node and JavaScript ecosystem that kind of crosstalk with Elm. So just so you know. Okay, so now we have the exact same thing. It's like nothing has changed, but now I can select a color and it changes. So what I've done, every time I select one of these, it sends a signal, propagates up through to the very top. The top level component says, I have an action called change color. I'm going to use that myself to change the color that I represent this large blob with. And then I render my view. So this is just what happens each time. Okay? So nothing fancy, but that's how communication happens from a lower level component up through the chain. I have 13 minutes. I'm going to try and go very quick. Okay, so, give me serious feedback. Is it confusing or weird or?
I got it.
You got it? Okay, she got it. We're good.
I've got questions.
Okay, question.
So if you've got, so your lower level component, is it, so two questions I guess, does the action bubble up or do they all have a reference to the top level?
Good question. And obviously you do web development because capture and bubble phases, but no, it doesn't. The Elm architecture takes those addresses and they actually literally route right back to the top.
Sweet.
Yeah, so.
Okay, so that answers the first part of it. And the second one is, when the top level has nested children, and some of them respond to that action and some of them don't, do something with that action, right? Do they still get that action? Or does it go to every child?
Okay, so the question is do actions propagate down to every child when one occurs? No. So, and it doesn't even follow, it follows the
address kind of mapping?
Yeah, it follows the action mapping, basically. The address, it's confusing, I know. The address basically just adds forwarding tags, and then those tags get stripped off as we go down. So there's a differentiation here between actions and like DOM events. So DOM events will act exactly the same way. They will bubble, there's a capture phase, there's all that. So actually you'll see that in what I'm about to demo here right away. But the actions themselves, Elm's actions, are very targeted. They will literally, you will find that most of the time they only ever go to the singular component that initiated them. Yes?
So can you think of the addresses kind of like onion routing, where you're like queuing off?
Yes, actually, exactly. I think you can think of actions that way. I would not think of signals that way. There is some confusion sometimes when we speak to people about what the difference is, but you're absolutely right. Actions, you build up as you pass these forwarding these forwarding addresses down. But all that serves to do is to identify on each component, what am I supposed to do with this, right? And so you're absolutely right in that. Yeah, so yes, onion routing is a lot like what actions are.
Was all that routing handled by the update function in the top level? All that pattern matching?
Actually, you handle it after the top level. So the Elm architecture, which is handled by the Start App package, if you look at the code for Start App, especially the simple portion of it, it's really small. All it does is it wires a few things together, and then you're handling it from there on. And so that sharding I was talking about before, that's you practically doing that. You're saying, okay, I'm stripping off this part of the action, and I know what to do with that. But what I need to do with that is update a piece of my model with this other action, and you pass it down.
And that stripping off is handled by the pattern matching?
Yes, it is. It's handled, so in the case statements you'll see, you can pattern match against some sort of action type, and then it has its constituent data types, if those exist. And yeah, you can basically extract those, for lack of a better word, as actual data, and then pass it down from there. You know what? I'll just go really quickly back to that, because that's actually it. Oh, weird. Yeah, maybe I didn't actually show that. Oh, here. No, that's not it. Okay, never mind. I'll show it. I'll show it after, definitely. Okay, so did I? Yes, I showed this. Okay. So, any more questions? Okay, so what happens, so I showed you how a menu can communicate back up to its parent or somewhere else. But what if that menu wants to make a change to itself, right? So we just showed the case where something happens on the menu, but the actual effect happened on its parent, right? So the actual top level thing that Matt made changed the blob color. The menu is unaffected other than we rendered it with a different selected value. So what happens if we want to maintain the state on the child that really has no place in the parent, and we want to send actions there? So very simple, very similar. What we do is we do the exact same thing. You'll see this. You'll see this is the pattern. This is why they call it the Elm Architecture. It's a very repetitive pattern, but it works. So we add actions to the menu. We create an update function, because before we didn't actually have an update function on the menu. It was just a dummy view. And so it accepts one of its own actions and itself as a model, again, type to A, which is whatever, as long as it's the same. And all we're doing here is taking over the cases where we collapse it or expand it. So we're going to just make it so the menu can collapse or expand. Super simple. But we also now need to tell the child, hey, here's how you talk to yourself, right? We told you how to tell us to select something. But we're going to tell you now, anytime you need to send an action to yourself, because you're growing up, you're a big component. Here's how you do that. So we define this new, so we extend the context, and this is why I like making context objects for this, or sorry, context records, because if you start off by just providing an address, you'll quickly find that a component actually needs a couple of these, and you'll see like, oh, okay, well now I have to go and extract it to an actual record type and change all. So I find it's best, if you ever end up doing Elm, I find it's best to do, just create a context. So anyways, so now we're saying, okay, it's a signal, an address from the signal package that accepts an action. And in this case, this action refers to the action in the menu, right? So, so that type is an explicit type. We're not saying it's generic. No, we must always get a menu action. I don't know what's going on. Sorry. And so then when we go to render it, I showed this before, now all we do on Matt's component, the top level component, is we just create a new forwarding signal to modify color menu. So this is a new action. Okay, I skipped something. Right. Okay. So we add this action, which is modify color menu. So this is where it's becoming explicit, right? We're going and saying, okay, when I render the color menu, I'm going to make sure that it has an address that appends this modify color menu tag to it, so I know which menu to update when I receive this as we strip off these actions. So, and it accepts just a menu action, nothing fancy there. We add the case, and here I'm updating the color menu that I added to the model before with just the generic menu update function, given the action and the model. So this is actually, like I say here, it's a concrete example of the sharding that I was talking about before. This is where we actually see that piecemealing off. And then this is, again, I was just saying, this is how you construct it. Really, you're just saying, okay, here's the address you used. I'm going to make sure it forwards to me, given this, so that I know we're talking about you. Okay, my hand is going. Okay, so let me just demo that really quick. Okay, so how does that look? Okay, so what do? We made the menu expandable. I'm not showing all the markup, right? That's just assumed that it's there. So now block color doesn't exist, but when I click it, oh, there it is. And that's the component talking to itself, right? The parent component, Matt's game, only knows that it's passing something down as an update. It doesn't really know the details of it. And so this is where that sort of ownership by implication happens. Yes?
Is the state for that still in the top level?
Yes, absolutely. The only thing that's changed here is that we've fragmented off a piece of the state which represents the menu itself. And we've said, okay, you are now expanded or not. But really, again, it propagates back up to this big global I hasten to say global, but this large piece that represents the application state. There's nothing more to say.
Is that what the model represents? The global?
Well, as you pass down through components, each one of those models represents the model that just encompasses that component, but the way it's truly stored when you run the application is literally as one large object. And the way the Elm Architecture actually enforces the use is through this update chain that I'm talking about, but it ends at the top. So the top level is literally holding everything. So, yeah. Does that make sense? Sort of? Okay. I can totally explain it after, yeah. But here's the other thing. So event bubbling for the people that are in the know. So not only do I click blue, traps the DOM event for blue, it's also because I added the event handler on the menu itself, it's going to also trap that event in the bubble stage and spit out an action to expand or contract the menu. So every time I click the menu item, it auto contracts. It's just because I was lazy, I didn't want to do a stop propagation. But the point is that what we're actually seeing two actions happening simultaneously from two completely different sources, so to speak. Yeah. So anyways, so that's that. So now we've got this fun little menu. I have 2 minutes. Sorry, everyone. I'm going to go over. It won't be much longer. Over.
That's okay.
Okay.
We've had a lot of questions, which is good.
No, it's awesome. Actually, I think it's super. I didn't anticipate questions like this. Okay, so the whole point here was how do we make something reusable? So you already saw that I was using generic types before, and obviously that's a huge component of reuse. Well, let's just show it concretely how we would do this. And then the last step I've left undone for the student to fill in for themselves. That means amazing. But anyways, you'll see what I mean. So up until now, we've done pretty much everything that we need to create a reusable component. And all we did was create a component that works in the Elm architecture. That's all we've done. So that's sort of a nice side effect of all of this. The way we built it, which didn't require a lot of complexity, made it reusable simply by iteratively modeling it. So take that for what it's worth, but I think it's important. So to reuse this, let's just add another menu. Let's add a radius menu. We change the radius of Matt's blob. So what do we have to do? We have to do the exact same thing we did before. We add an action that changes the radius instead of the color. Well, sorry, I guess I should say we create a radius menu, which is a menu model, but this time not color type of type float, right? So it's a composite type in some ways. We give it some values, and then we have to give it an action so that we can actually say, oh, hey, you know, when I get this action, I know to modify the radius menu and not the color menu. So just like we did with the color menu. And we just cover those cases in the update function of Matt's game. So all we do is change radius, modify radius menu, and those are just passing down the model with an update, updating the model itself on the global applications. We render it exactly the same way. We just send it a context, but this time we're changing the addresses that we tag to it, right? But the context is exactly the same, and we render it exactly as we were. But now, okay, so here's the bottom line. Obviously, some of you are seeing a pattern here. So this is where you go, hold on a second now. Do I need to keep renaming and retyping all these things? Maybe there are other ways to formulate my data so that I don't need to explicitly name a radius menu, name a color menu. You can, I mean, this is the part I was saying. This is left up to the student or whatever. This is your exercise, but it is very easy to do this. And that's actually one of the things I like about Elm is that I was able to create some things in the past where at first it was very explicit. I was naming things very explicitly, but as soon as I saw that there was a need for 0 to n of them to refactor it to that point was not difficult. It was really nice. Not that it usually is, but I was worried that it would be. Hold on, let me demo it. Well, I have to prove that it works, right?
You can't see any of those fancy error messages.
Yeah, well, Matt showed the error messages. Okay, so now we have a blob color, which we can still change. Okay, everything's good. We also have a blob size, so we can change that guy too. Both of those act exactly the same way. You know, this is like, again, for those people who are React users, like this is nothing new, obviously, and nothing new in a lot of ways, but effectively this is how it works in Elm. So yeah, so we've got two independent menus, both using the same code, sharding the model, everything is great. So thanks everyone thanks for the question.
That was awesome. That was really good. I wasn't expecting to be that excited, actually. Nice.
Are you rewriting feathers in Elm now?
No, but actually, funny enough, so Tice asked if we're going to rewrite feathers in Elm. No, at least not right now. But we had somebody write, because we got a chat example, and we had somebody from the community write an Elm, and contribute it to the example. So we got an Elm version of the chat example with working with feathers, which is kind of cool. I don't know what it does, but it works. Yeah, so that was part of the reason for me to actually be able to see what we're doing. I want to thank you guys again for putting together an excellent presentation on a pretty, I think, at least for me, some of this was definitely over my head. I was saying to Matt, it's been a long time since I did functional programming, and I totally failed it in university, at least the first time around. And so I think, I've done a bit more now, but in terms of JS, but it's kind of interesting coming back to some of it. So I think for me, I'll be going back and watching this, and we'll have this up online. And with that segue, I'm going to stop the broadcast.